Hi Calculus. In the last video I was talking about if the second derivative is positive, that part of the graph is concave up. If the second derivative is negative, that part of the graph is concave down. Now what we're going to talk about is the significance of when the graph changes concavity. If it changes concavity, that's called an inflection point. So if a graph changes concavity, we call that an inflection point. The inflection point is the moment when it flips from either concave up to concave down or vice versa. The inflection point can only occur when the second derivative is 0 or undefined. Okay, so just like the critical number, it's the same idea. And just to sort of give you a sense of like the significance of this, like this would be a popular thing that business models would look at, because at the point of inflection the slopes are still increasing, but at the moment of the inflection the rate of the slopes increasing is slowing down. So the rate of the rate is slowing down. Okay, so the slopes are increasing, the tangent line's very vertical, and then it starts to slow down. The tangent lines are still increasing, but they're slowing down in the rate that they're increasing. Okay, so let's take a look if there are any inflection points on the previous problem we just looked at. So if you notice, an inflection point can only occur at a critical point, which is when the second derivative equals to 0 or it's undefined. So if you notice here that it switches concavity, which means that this indeed would be an inflection point because there is a change in concavity. So at 0 something we have an inflection point. And here you can see that it changes concavity. So at 1 this would also be an inflection point. So we are going to want to draw the inflection points on the graph. So you're going to need to know the exact point in space where the inflection points are. So to do that, that means that you have to take that x value and plug it in to find its corresponding y value, which means you need to plug it into the original because you want the point in space. So if I plug 0 into the original, the y value out is going to be 0. And if I plug 1 into the original, the y value out is going to be -1. So this is its xy point on the graph. So again, inflection points occur when the graph changes concavity. I'll pick up again in the next video. Bye-bye.